So we are now at the 1 o'clock session with the title AI and Machine Translation. We have Massimo Rivo, who is the Brown representative, along with Ellie Pavlik, who represents Brown's Massimo Rivo from Italian Studies, Ellie Pavlik from the Computer Science Department. Next along the line is Marina Carpuet from the University of Maryland's Computer Science Department. And following at the end is Dan Garrett, who comes to us from New York City and works at Google DeepMind. So if you're interested in their profiles, they're available at the website. And we're going to start with Massimo. Thank you very much.
Thank you very much, Jane. I'm a little out of my depth on this panel as far as the technical grasp of how generative AI actually works. My perspective is that of an end user trying to assess the potentials and limitations of the apps coming online. So consider what follows a very brief opening up. So slightly changed title, translation and simulation seemed too dry to me. So literary translation as simulation and meta conversation part 1. So I'll begin with an idea of literature that took shape in the 1960s, a definition of literature taken from Italo Calvino's 1967 essay, Cybernetics and Ghosts. Literature is a combinatorial game that pursues the possibilities implicit in its own material, but it is a game that at a certain point is invested with an unexpected meaning, a meaning that is not patent on the linguistic plane on which we were working, but has slipped in from another level, activating something that, on that second level, is of great concern to the author or his society. Since translation is a crucial dimension of literature, it can be also considered a kind of combinatorial game, one that involves at least two languages and the attempt to say almost the same thing in both languages, as the Italian semiologist Umberto Eco put it. In other words, translation is the art of the almost. Foundation models and transformers like LLMs, etc., bring this combinatorial game to a new level and perhaps a new precision. While I'm curious about the possibility of designing a kind of literary AlphaFold applied to whatever the literary equivalent of a protein structure might be, I'm even more curious about the many varieties of reversible Turing texts or games that we can perform and play with our AI literary assistants. The crux of these games is still that slippage, that swerve that Calvino talks about, the unexpected behavior or meaning, or as the 2022 Stanford report on the opportunities and risks of foundation models calls it, the emergence that our interactions with the deep learning machine can trigger. So I had the brilliant idea to ask ChatGPT what it thought about my idea, that translation can be considered a kind of simulation. I'm pleased to report that ChatGPT found the idea intriguing. The concept, in this context, simulation refers to the process of replicating, etc. You can read the slide. Prompted by me, ChatGPT came up with 6 ways of aligning translation and simulation. Sorry, for some reason. Okay. 6 ways of aligning translation and simulation. The choice of words is GPT's, not mine, while alignment is an established procedure in machine translation and the formation of translation memory. In AI jargon, alignment, correct me if I'm wrong, may also refer to the process of encoding human values and goals into large language models to make them as helpful, safe, and reliable as possible. In any case, that ChatGPT understood the relationship between translation and simulation as alignment is an interesting slippage that, as we shall see, prompts some speculation. So you can go through quickly if you haven't done so. Why don't I move this up here? It's much easier. What do you think? Yeah. Okay. Can we rearrange a little bit?
Yeah,
Because
of course.
otherwise I
do
have to
this
step
here,
away from the.
and then you can do this like this here.
Ah,
Is this better?
much better,
Much
much
better.
better. So I then asked ChatGPT to give me an example for each category, and here's what it came up with. So replication of meaning and style. Example, Gabriel Garcia Marquez's 100 Years of Solitude translation from Spanish to English. Replicates Marquez's magical realism and lyrical style, the same poetic, etc., etc. Cultural stimulation, translating Haruki Murakami's work from Japanese to English, simulating the nuances of Japanese life, such as traditional customs or urban living. Emotional resonance, translating poetry, such as the works of Rumi from Persian to English, deep emotional and spiritual undertone. And of course, all these examples are translation from whatever language into English. The only exception is, of course, translation from English into other languages is explained by the global popularity of the Harry Potter series. By the way, I like the coupling of Harry Potter and Zarathustra, which after all are both magicians, no? I mean, so I found alignment number 6 more interesting. The cybernetic loop applied to the entire literary process with all its agents, including translators, critics, scholars, editors, readers, could be a premise for building a translation model with multiple parameters, perhaps one based on multiple backpropagation algorithms. I am hoping not to misspeak here because I'll be corrected anyway. So I then asked the obvious question, and of course the answers were simply iterative or tautological, simply reiterating the reasons why the authors were chosen in the first place, reflecting a world-lit model implicitly built into the training data, one clearly streamlining the patterns of the largely American content that these systems are trained on. Nothing like the alternative prismatic model of world work illustrated yesterday by Matthew Reynolds, I believe. So note how from its conclusions, here are the other examples, I mean, going quickly through, you know this, from his conclusion, basically, yes, let's skip to this slide. Of course, I got a little annoyed that no examples were taken from Italian literature. And ChatGPT was quick to make amends for the oversight, recognizing that Dante's comedy definitely qualifies as a world-lit model work. Yet ChatGPT also added an interesting prompt of its own. Translating Dante's Terza Rima is incredibly difficult to replicate in English while preserving the poem's original rhythm, meaning, and rich imagery. This reminded me of what the poet Robert Pinsky said when asked about his translation of Dante's Inferno and whether poetry is essentially untranslatable. Yes, he answered, poetry is basically a technology of the sounds of language, and one set of sounds is not another. But as a work of imagination, one can, to use a very old term, English a work of art into another derived work of art, meant to give pleasure and an idea of the original in the new language. So, question, can an LLM produce a derived work of art beyond the technology of the sounds of language, beyond its own material, the linguistic plane, to use Calvino's phrasing? This leads directly to my conclusions. Perhaps AGI models with millions or billions of parameters will be able to perfectly align the different tasks that a human translator embedded in a specific language, culture, and society can only approximate. To be sure, ChatGPT seems aware of its current limitations, the challenges of semantic ambiguity, the limited breadth of context windows, etc., etc. However, alignment remains the machine's primary goal or prime directive. In the combinatorial game, the goal of the machine, for the moment at least, remains that of simulating the way humans might infer meaning and context to produce coherent and nuanced translations. But what about the human goal? What's our end game? So, in conclusion, I must admit that this preliminary or meta conversation with ChatGPT about translation as simulation was a little disappointing. Introducing the simulation variable, I had hoped for a potentially new take on the old Italian adage, traduttore, traditore, translator, traitor, something like translator simulator. As we are experimenting in AI-assisted translation, not from Dante's Comedy, but from another Italian classic, Boccaccio's Decameron, the real test for the art of the almost is to be able to render or simulate humor, irony, ambiguity, double entendre, etc., of which Boccaccio, of course, is full. Having tried my hand at translating a postmodernist master like Bob Coover, I can assure you that that's the ultimate test for a human translator as well, and translators would probably agree with me. When I asked ChatGPT, it retranslated for me the adage into Italian, adding a little comment of its own. Something is always lost in the art of translation. What I got in the end from this first chat with my AI personal assistant is the confirmation that more than stochastic parrots, LLMs are the new chameleons. Quoting Aristotle in one of the foundational texts of Renaissance humanism, Giovanni Pico della Mirandola famously stated that man, the human being, is at core a Proteus, a chameleon, a shapeshifter, can simulate, thanks to language, can simulate every existing being and even imagine non-existing ones. Interestingly, the only time a chameleon shows its real colors is when it touches another chameleon. Thank you.
Is it okay if we just scroll down? Yeah. Yeah? Okay, I'm just gonna, oh, sorry. That way I can see the comments. That's true, yeah, so I would just leave it and then just kind of scroll it this way. Okay. And just make sure that it's like, yeah, it's you.
Great. Okay. Hello, everyone. Thank you. Like Jane said, I'm from the computer science department, and it's really nice to be here and talking with so many people from across campus. So I titled my talk AI as an Advertisement for Liberal Education, which was for Jane's suggestion. She invoked the ultimate academic flattery, which is quoting me back to me and saying that I had said this in a panel. And I was like, that is a great quote. Like, God, what an insightful thing I said. But I mostly wanted to, so I don't work in translation per se. I work on natural language processing and specifically on large language models. But something I'm very interested in is the kind of opportunity that language models are presenting us right now to revisit a lot of these really big questions from the humanities about language and meaning. And I think some of the themes that have come up in the workshop yesterday and today that are specific to translation, but I also think more general than that. So I was going to talk about kind of this broader case for the collaboration and what kind of the arts and humanities and the kinds of people in this room can provide to AI right now. And then talk about a few specific projects that I've been working on that I think kind of represent this in the space of trying to understand meaning and as it's represented in these models. So I think it's helpful to just say explicitly some of the ways that people are talking about how AI might be used in the arts and humanities. And I think this is actually probably the more common side of the discussion of what people are talking about right now. Since I'm scrolling, I'll just put all my bullets up at once. So there's a lot of talk about using things like generative AI and large language models as part of the creation process. So you can imagine artists using them as tools to, explore space or to get ideas. There's a lot of interesting examples of poetry composition, for example, where it's kind of done jointly with ChatGPT. There's also a likely case that a lot of people will just, circumvent the artist, so to speak, and go straight to the language model, like tell me a story or tell me jokes. Like people are playing with it like that. So this is kind of like a way in which generative AI is like somehow in the loop now, creating text and art and things like that. And then translation as well. So Maureen will talk about machine translation explicitly, but obviously people are already using this. Probably one of the most widely used use cases of AI right now is for translation. Like I log onto a website in any language other than English, and I can just click this button and get it translated. And so there's a way in which like many people are using and taking advantage of this machine translation without even, giving a second thought. So there's like, so this can happen for literary translation, but also for just much more, kind of utilitarian translation, like a train schedule or something. But there's also an implicit way that people will be taking advantage of translation through this generative AI. Like you can imagine asking ChatGPT questions like we were in the talks yesterday, and like, who is this Chika Sagawa? I've never heard of her. So if I ask that in English to ChatGPT, it's probably going to be sourcing from English, but also possibly non-English texts and talking back to me in English. And that becomes my relationship with this poet and her poetry, right, is through this kind of a filter. And then kind of like we're just hearing about, I think a really major way that people are going to be using this is basically to evaluate and analyze and interpret art. Like you think about students consulting generative AI, which they might do explicitly, like going to ChatGPT, but increasingly this might be used to seed stub articles that they don't even know they're seeing from AI or being plugged into search engines, where now the kind of criticism they're getting for things that they're reading is coming through this generative AI lens. And then, of course, to curate, so people are increasingly using it for recommendations to decide what to read next or what to look at next. So we think about all these different ways that large language models, generative AI, are kind of part of this process of the humanities and of things like translation. And that kind of creates this world where there's now this new set of questions that we need to deal with that are like very real and very tangible, right? So I think one of the main ones that I want to focus on for most of the talk today is this question of meaning and understanding. This is something that has it's an age-old question, right? Like philosophers have been talking about this for as long as there have been philosophers of, how do words or something like images acquire meaning? Where does it come from? How does it compose? How is it represented? But now we're faced with language models that are generating text, they're reading text, and they're writing text, and we have to try to understand what meaning that text carries and where did it come from? Like, did the language model, where did it inherit it? How do we understand something that was written by a language model as opposed to a person? So I'm going to focus on a couple kind of concrete examples, but I, like in sitting through the talks, especially yesterday, there were some other themes that came up that I just think were really interesting as something that could be explored, discussed in these kinds of venues. So one is this notion of like the original, right? Like what is the original text, or this kind of prismatic view of various texts. I really liked that word. So when we're like looking at something like a language model, and again, you think about how many people's relationship with a text might be through these search engines that have gone through not only the AI filter, but an AI that has slurped up everything everyone has ever said on the internet about this, which is obviously not what everyone's ever said. So there's like the kind of how is that a biased set of things? But he's slurped up all this text and now is kind of regurgitating it as an authoritative whole. Like this is what this book is about. This is who this poet is, that kind of a thing. So I think there's really practical questions about originality and creativity where the language models, how do we credit the original creators and things? And there's also this kind of scholarly question of what does that mean for our relationship to these different texts? And I think that's a really important question to explore that we'll increasingly confront. And then there's this other question that has come up before kind of in the classroom setting when we're thinking about like a kind of a liberal arts education is like so there's like language models are just factually wrong all the time. And that's like, as a computer scientist, we love to exchange on the faculty mailing list, like, look, people asked it to do this proof and it just came back with a completely wrong proof. But that's like the easy case where we can just say like, that was a wrong proof and this student now looks really dumb for having used it. But when we work in the kind of humanities, there's like a much less clear notion of like what is or isn't a good criticism or what isn't a good argument. And so I think it gives us this really good opportunity to help students like think really clearly about how they're evaluating a particular opinion and deciding whether they believe it, right? So it can be sometimes hard, I think probably for students in for anyone when you're like reading opinions of experts and saying like, how do you decide whether one is good or bad? I deal with this with students a lot when I work on interdisciplinary courses. Like here's a philosophical argument for why meaning is or isn't this certain thing. And students kind of just defer to authority a lot, right? Like this person said it must be true. When you see something from a language model, it's easier to make the case like this might be wrong. And I think that kind of creates a good opportunity to think about like, how are we going to decide what we believe when we're presented with an argument? So I think there's a lot of these ways where the kind of what we're doing in the humanities and in these kinds of settings, like the existence of AI at the quality that it currently is, like forces us to actually address these issues much more substantively. And these questions are really like core scholarly questions that now need to be answered because of the presence of AI. So I wanted, like I said, to talk about a couple kind of specific projects and examples in this realm of meaning and understanding, because this is a topic that's actually, I think, a really good example of like, computer scientists working on building AI as this technical problem and kind of accidentally wandering into this kind of area that is fundamentally a humanities kinds of questions. And this has been this argument about meaning. So I think this has been going on for a while, but it recently kind of came to the fore. It's not that recently, maybe 2020. This paper was published in one of our big language processing conferences, which was criticizing the language models of the time, which are very bad by today's standards, I should say, because a lot of people had been saying that these models understand language, that's the phrase, and they mean this or that or the other, and they were criticizing that this isn't true because of the way that they're trained. They're just slurping up text and finding associations between words and parroting it back, that these really are not meaning and understanding. And it was very provocative. It's also, I think, an interesting example because now you have a paper published in a computer scientist conference with section titles like "What is meaning?" and then about 2 paragraphs underneath that just give kind of an answer. Of course, they give a little more nuance than that. But shortly after this, it caught attention and people start to pile on. And so there's an example, John Cayley had shared this list of things coming from like kind of the literary arts world where there are analogies to this much older kind of thought experiments about what if the ocean were to wash up into the sand and happen to produce a pattern in the sand that looked like a poem, like what does that poem mean? And so you can see a lot of these arguments that were had in that world now are being rehashed in the world of language models, but again, where people working on language models maybe haven't ever heard those arguments before. There was a debate at NYU last year in the kind of philosophy and brains, minds, and consciousness group that was again kind of like, hey, this argument that's being had like on Twitter among computer scientists actually sounds a lot like arguments that were had hundreds of years ago among philosophers about what meaning is. And so there's like this rehashing of some of these questions. And so this original paper kind of, if you've studied these things, it makes kind of a confused argument that cross-cuts a lot of fundamentally different philosophical positions about what meaning is, right? And 2 minutes, okay. And as you get back into it, you can see that. So there's this kind of exciting chance to revisit some of these questions. So it's kind of these old questions, but they suddenly feel new because we have this concrete artifact that we can use rather than these thought experiments, we can say, okay, this is what the model is doing. Like, does this count as meaning? Or what does this afford? Like, what kinds of meaning do we or do we not get from these various things? So I was going to go through a couple quick examples. I only have 2 minutes, so I'll go very quickly. But like one example of the kind of thing we've been studying is this need for like sensory grounding for meaning. So there's often this, we were hearing earlier today about the word-world association. And so there's common assumption is in order to have meaning, you need to have some connection to the actual world. And language models, by most kind of traditional standards, don't have that. So we were looking at how this might affect something like color words, and we found this interesting phenomenon where basically they have this kind of spatial understanding of the color landscape that is that allows you to map onto the real color world very, very faithfully. And so there's kind of this, you can kind of put in more concrete terms this argument about like, does the model really understand color or does it not? And you can get this kind of empirical results that suggest it has a lot of this meaning of color, even despite not being able to perceive. Another kind of example of something we could look at is a kind of an old philosophical question of this synthetic analytic distinction that we talk about in word meaning. So There's been a lot of work on bias in translation, like gender bias. And here's this example, like if you ask to translate from a language without gender, like doctor, into a language with gender, the model might make assumptions about gender. And in this case, actually, it's explicitly contradicted in the source text, but other times it's just inferred. So here it's assuming the doctor male, assuming the nurse is female. And so this is kind of a phenomenon of machine translation that warrants its own discussion. One of the things we've been trying to understand is basically where does a word like doctor encode its gender information in the language model? Because there's different mechanisms where this could happen. And one is what we might call the analytic one, that it is part of the meaning of the word. So doctor is male in the way that man is male or king is male, right? And then there's other versions where you would say doctor is male in the way that like Beats Music is owned by Apple, right? Like a fact about the world, we call this synthetic. And because we have this specific language model, we can dig into mechanisms and say, for this model, like how is it representing that information about meaning? Where is it introduced? Is it part of the meaning of the word? Is it something from the context? Is it something you know about the world? I think that opportunity to study these things very concretely is very exciting for the understanding of meaning. All right, so I'm over time, so I'll stop. But as kind of my general takeaway is that I think this kind of success of large language models and their failures open up a lot of these questions that are fundamentally not computer science questions, right? Like these are questions that really connect to the kinds of things that everyone in this room is studying. And humanities has a lot of tools and methods for how to answer these questions. So I think there's this really nice, something like a passing of the baton where AI is not really a computer, like that's not like in the domain of computer science, the way translation doesn't like belong to a department. And some of what I think the most exciting questions in AI right now have like left computer science, right? So there are still technical questions, ways to make it better, but some of these questions we're talking about, like what to do with the kinds of models we have, are really not computer science questions. And so this is the kind of, I think, a point of discussion here. Thank you. I'll pass it off.
Oh, sorry. This is not. There we go. Okay.
I'm going to put this here if you don't mind, so I'm not hidden behind the screen.
Just make sure that you pass.
Okay. All right. Good afternoon, everyone. I'm Marine Carpua, and I'm really happy to be here. It's been a pleasure to hear so many different perspectives on translation. I think about translation a lot too, but as someone who's trained as an engineer and a computer scientist. So what that means is that I spend a lot of time working on machine translation, building machine translation systems. That's a very old area in computer science. People have been thinking about how to use computers to translate automatically between languages pretty much since we've had modern computers, right? Like around just after the Second World War, where there was all this work that had been going on cryptography. People started thinking, what if we thought of English as just Russian that's been encoded into English? And what if I can crack the code? Maybe I can automatically translate it back into Russian. As is probably clear to everyone in this room, it's not that simple, but work has continued ever since. And today, machine translation is a form of what we now call generative AI. And it's a technology that's used by a lot of people in their daily life with apps like Google Translate that most people can just have on their phone. So it's powered by the same kind of underlying models and tools like ChatGPT and all sorts of these large language models. And it has a lot of the same kinds of strengths and weaknesses. Because these tools have been out there for much longer, though, than ChatGPT, we know how they're used. And it's both really exciting to see these tools actually used, but it's also really worrying, because people use them even if they cannot verify outputs, right? Because after all, the people who might benefit the most from a machine translation tool are the ones who do not speak one of the languages that they're trying to understand or communicate with someone. So they use the tool, they might translate it, but they have no idea whether that's a reasonable translation or not. Yet, they rely on these outputs all the time, even when the stakes are high. We know that machine translation tools are used in hospitals, in courtrooms, in immigration proceedings, when people prepare their cases for asylum applications, for instance, or even when people evaluate applications. And so that's really worrying, right? Because translation errors in those settings can really have harmful consequences in people's lives. So this realization has changed a little bit the kind of technical work I do. A big part of my work is just how can we just build machine translation systems that produce reasonable translations? And I still do a lot of that. That's definitely not a solved problem, especially for the vast diversity of languages we have in the world. But at the same time, I've been increasingly thinking about how can we, instead of trying to chase perfect translation quality, can we also just acknowledge that these tools are imperfect and that even as they improve, they're going to continue to make errors? And how can we design the technology to help people rely on these imperfect tools in a way that's still helpful? So let me give you a little example of what that means. So imagine that you're a doctor here in the United States. Maybe you work in an emergency room, and let's just say that you only speak English, and you have a patient that only speaks Chinese. So, a common part of the process is like when you discharge the patient, you summarize what you did, you tell them the diagnosis, and you tell them what medication they should take, what symptoms they should pay attention to before coming back, or things like that. Doctors in this situation often use Google Translate to take clinical notes that they've written into English and show a translation into Chinese to patients. So in this case, this is an example of a sentence that was taken from a discharge note. We run it through Google Translate. Is this translation correct? Does it contain errors that might have clinical consequences? If the doctors only speak English, they have no idea. Yet what do? They show it to the patient because they just assume that showing them something is better than nothing. So can we do better than that? So we have collaborators in human-computer interaction and also in the medical school at University of Maryland, my home institution, UC Berkeley, and University of California, San Francisco. We tried to do a little study when we presented different types of feedback on the outputs, the quality of the translation that were produced by a machine translation tool to doctors, and try to figure out whether it helps them rely on the translations more appropriately. So we considered two types of feedback. The first one is really kind of the AI expert way of doing this. So we were drawing on decades of research in natural language processing on automatically assessing the quality of a translation. So how that works briefly is just you can think of it as a large language model that is tuned specifically to mimic human ratings of translation quality. Crucially, these human ratings are judgments that are collected outside of any context of use. So it's just, in general, you show people examples of inputs and examples of translation, and they just rate, is it adequate, is it fluent? But there's no notion of what is this translation used for, and it knows nothing about the medical context. So we use these tools, and then that lets us give people something back, for instance, telling them the translation preserves some of the meaning of the source, but it misses significant parts. And then we compared against another approach, which is what people do when they use these tools. And that's translating back into the source language, right? So maybe you have the original English, it's been translated into Chinese, you don't read the Chinese, so you translate it back into English and then just look at, does this look plausible? That's very easy to do, just one click of the button, right, to reverse the translation. So people just do this all the time. But it's a little bit worrying if you know how these tools work, because it can be very misleading. If you see that the final translation is wrong, you don't know whether it was an error that was introduced in the second pass. Maybe the first pass was correct, but the second pass was wrong. Or maybe the first pass was wrong, and then the second pass somehow, glossed over the error or fixed it. So that's not a great signal, but we know people do it. So let's see whether that's helpful or not. So we did a randomized study with physicians in the US who are monolingual English speakers, and we showed them translation outputs, and then we showed them these different treatment conditions where they look at these different types of feedback. And we give them examples of, like, in the full context of the English text, some translations, and we ask them, would you give this translation to a patient who only speaks Chinese, and how confident are you in this decision? So, just on the basis of this, and also when they have access to further feedback. And then what we measure is how well they agree, how do their decisions agree to the decisions that bilingual physicians who understand both the Chinese and the English would make. And we call that measure confidence-weighted accuracy. So what we found is that reliance, like physicians' ability to make the right decision, improved with the AI-based quality rating, but not with back translation. And that's interesting because back translation is what people do, and it tells us that this gives them a false sense of confidence that they're using the tool well. They're taking a step towards verifying the output, but it actually is not a useful signal. So, that's something that we should take into account when designing these tools. But interestingly, when we look not just on average, but specifically at the subset of examples that contain mistranslations that had some clinical risk, where the bilingual doctors said this translation error is problematic from the perspective of the health of the patient. We found that with the AI-based quality rating, people were often misled into thinking the translation was good enough. And when they used the back translation, they were actually able to detect these clinically risky examples better. And so that's really intriguing, and it suggests that there's a complementarity between these two approaches. Maybe the AI tool is better at identifying when translations are good, and the back translation, my hypothesis is that when showing the full back translation output, it forces people to pay more attention, to read more carefully, and so to think more critically, perhaps, about what might be going wrong. And in our study, they were able, in that way, to detect the clinically risky examples better. So clearly this shows that there's a lot more work to do in terms of designing better AI tools, not only to translate, but to automatically detect when there are errors and when these errors can have important consequences. And so that's definitely some of the work that we are doing in my lab today. So this is just one small, tiny example of the kind of work that we need to do to design more reliable tools that people can use reliably even when they're imperfect. But there's definitely a lot of other things we can think about. So one direction that I'm focusing on is moving away from one-size-fits-all systems to more adaptive tools that can be adapted to different contexts of use. And by that, I mean not only training models on the kind of language that we want translated, right? Maybe if we're doing medical translation, the model should be trained on text that is relevant. That's good. But beyond that, how can we think about designing the tools and the interactions with the tools in the way that support the context of use better? So for instance, what knobs can we give people so that they can control the translation, so that it's not just one input, one output, and then use it or leave it? Can we have techniques in research that let you give some preferences in terms of the terminology that you want used, or some words that you do not want used? Can we let people have more control over the style or the tone of the translation? Or when we're incorporating a translation tool into a conversation, can we provide mechanisms to help repair communication breakdowns, right? If there's a miscommunication because of the machine translation tool, we should make sure that the tool is blamed, not the speakers. So there are lots of interesting technical questions that we can think about here in terms of how to design tools that can do all of that and not just take one input, spit out one output, and then let the user deal with it and hope for the best. Another different but complementary direction is trying to move from thinking of machine translation as a seamless technology to taking an approach that aligns more with simple design. So let me tell you what I mean by that. As technologists, when we think about translation or technology in general, we think it's good when technology is seamless, when we use it and we don't even notice it's there. It's in the background, it does instantly, we don't notice it. And that's definitely good for a lot of technologies. But I'm wondering whether perhaps for translation and for a lot of the generative AI tools that we have today, maybe that's not the best strategy. I think it's very clear from everything we've heard yesterday and today that translation is a very rich and complex process. It's not neutral, it's not transparent. And perhaps machine translation tools should not pretend to make it look so. So this connects with the idea of simple design that comes from ubiquitous computing. And it's the idea that in design, it can be good to strategically reveal the seams or the cracks in the technology so that we can help people be more aware of the blind spots and the limitations of the technology, and so that they can use it more reliably. So in the context of translation, my hope is that thinking along these lines will help us come up with systems that do not just take one input, produce one output, but also give more agency to users. Also help them develop more appropriate mental models of the technology, and perhaps develop better forms of literacy around AI and around translation. Thank you.
Yeah, let's put it up here.
Okay.
Hi. Okay, so I work on multilingual language models, and I want to talk a little bit about like what it means to try to build these things that have kind of taken over the discourse of what we're doing. So, language modeling in general, I want to kind of give us a shared grounding, and the term language model has changed a lot over time. But what I'm going to talk about here is the kind of fundamental way that the things you're probably familiar with, like the way that GPT and Llama and Gemini and all these models work. What a language model is a function that takes some language context and predicts what the next token should be. So it's continuing a sequence. And so what that looks like is you can have some sequence of language that comes in, trying to predict the next thing. So this is the context. And then the model will say, okay, what the next token is. And I'm using the word token very specifically as opposed to word for reasons that we'll get into. And so the choice of like what token to choose comes from this thing that is the vocabulary, and the vocabulary is some set of stuff. And the model's job is to score the things in there and basically say like of all these things, what's the how good a fit is a particular token for being the next thing. And so here, maybe that's, thinks the word jumps has a good, so, it chooses that and that becomes the next thing. And then, as this continues, that becomes now part of the context for the next prediction. And so this next token prediction is what it's really doing. It's really doing this one token at a time process. And so we can keep doing that until we get to, the end of things. So this thing of like predicting one token at a time, it's very simple, right? But it is doing complicated things as well. So I want to point out like, some things like, okay, maybe the word jump is in our vocabulary and but that's not grammatical. And so the model should actually see like, okay, that's not a good candidate for choosing things. But if if the contexts were different, if it was plural, then all of a sudden it does look like a good one and the one that was chosen before. So the model has to know something about how grammar works, right, in order to make this choice. It also has to know something. So maybe the word spoke is in the vocabulary. And it's grammatically correct, but it doesn't fit, right? Because foxes don't speak, right? Like that's a thing about the world that the model would need to know. Except if we change the context and we said something about like, we're specifically talking about anthropomorphic foxes, now all of a sudden it like, looks like a good candidate, right? So this is the way that we use language all the time. The context matters a lot. So this thing of it's making a plausible next token prediction. So trying to understand how language works, trying to understand how the world works. A multilingual language model is one that we train on lots of languages. So the advantage of doing this is that when you have lots of languages together, they all kind of teach each other, right? So you have this problem of some languages you have a lot of data, some we don't have much data. Putting it all together brings it together. The other thing that actually came up in the previous panel, which ties in really nicely, is that the notion of a language is not really a discrete thing. And so trying to build a bunch of separate models for separate languages quickly becomes kind of a complicated exercise. But if you say like, oh, like we're not going to worry about the boundaries between these things. And so that's really works well when you have like mixed language inputs. The model should just be able to work. Another thing that's really exciting, just as kind of an aside, I'm talking about text here, but like the multimodal stuff is sort of taking off. And this is another interesting direction because for instance, things that look very different when written might sound very similar. And so all of a sudden, if the model understands both speech and text, it can actually find the similarities. Or images, right? Images are a way to learn about the world without having to go through any language, right? So you're not sort of coloring by the corpus that happens to be in a particular language to learn something about the world. So those are things that will take over more over time. So okay, so learning how a language works, right, in a multilingual model means learning how all languages work simultaneously, right? Challenging. How does the world work, right? That's like understanding how the world works in all languages. So this notion of like how language works, right? I'm putting this intentionally in scare quotes, right? How it works, right? It depends on a lot of things, right? So grammatical function changes. Does the subject come before the verb, or does it, or is it a free word order thing? That is a way that the model has to learn for every language that it interacts with, whether the subject comes first or not. That's not a thing we explicitly tell it. It has to learn how morphology works, right? What is morphology doing to the words and these things? So these are different paradigms of how morphology, or just kind of the way it's written in general, right? So languages like Chinese, each symbol might represent a word. In languages like Cherokee, each symbol represents a syllable. In languages like English, each symbol represents a sound. The model has to deal with all of these things simultaneously. It has to understand like the granularity of the thing coming in is very different. I always like to give the example of Hangul as well. So if you're not familiar with Korean writing, it's a system that each colored symbol here represents a sound, but it's written together as a syllabic block. The computer generally sees the syllable instead of seeing the individual parts, which, just complicating the understanding of that in general. So how language works, also pulls into these other characteristics, like some languages work by pulling in other languages, right? And you would expect in certain languages to see other languages popping up. Right, so like English showing up in Hindi is very common. Mixing French and Arabic is very common. A lot of this obviously ties into colonial history, and so we can see why these things are the case, but they are in fact the case. Understanding how the world works in the hand. So information is unevenly represented in different languages on the So if you look at Wikipedia, right? So English is the dominant language on Wikipedia, but there are a lot of languages there. It's important to note, however, that it is not the case that the English Wikipedia contains all of the other stuff, right? It's actually separate subsets of things, because a lot of the information that exists in the world is culturally specific. So sharing this information, we should be able to the question this thing earlier of you should be able to ask a question in one language and retrieve knowledge that is stored in another language, because the languages that have small Wikipedias still contain interesting things. There's also just kind of the knowledge of the world is also culturally and linguistically. So I learned this actually recently, but I think it's a really fun thing. What color is the sun sounds like a factual question, right? And actually, if you plug it into Google image search, in English, you get a bunch of yellow suns. And if you do it in Japanese, you get a bunch of red suns. The sun is not actually either yellow or red, right? It's but telling children you have to draw it as too bright to see doesn't really work. But this is a thing. It's feels like knowledge, but it's colored. And so thinking concretely about how this works together with translation, right? So we can treat a general language model as a translation model by giving it some context that informs, so if our context is, English : something in English, you hit enter, and then, French : so we're still doing the same thing, right? We're still doing next token prediction. So the model has to, look at this context, try to predict the next thing. Here, right, we would hope that it's gonna, see that the word it needs to translate is the, right? But in French, there's multiple ways that you can translate the. So what does the model have to do? Well, it has to look at other words that are part of the context. So it sees, fox, and it's okay, well, it can't be plural. It's got to be one of these others. It picks one of them. It moves on. That becomes part of the context now. And it's okay. now it gets to this thing where, okay, the order of the words is different. So now it has to translate, it has to skip over the quick and jump to the other one. And so it has to decide now which of these words, and it's conditioned on the fact that it had just produced the masculine le. Now, for people who do translation, it's probably very jarring to think about the fact that you're not doing these things together, right? You have explicitly chosen to output the word le before you have chosen anything else, and then you're forced to choose the masculine form of fox because you have already chosen. Right? It's very strange, but that is how it works. We can continue, and we eventually get to the end. So I want to talk a little bit about like how this breaks down more specifically. Okay, so things like how do we turn some text into these tokens, right? And what is this vocabulary all about? Trying to investigate these things quickly shows us the problems with trying to do sort of all languages together simultaneously. So, how should we split things into words, right? If you're an English speaker, you're probably like, spaces. Spaces sound good, right? Some languages don't use spaces, right? So some languages use spaces differently than, so, Thai apparently puts spaces between sentences. Some do between clauses, some between syllables. German famously puts a bunch of things together without spaces where we would put spaces, right? So just like relying on spaces is not going to work. There's things. Okay, well, what about punctuation? That seems pretty easy, right? You just separate the parentheses away from stuff, or numbers. Except okay, well, when people are writing in transliterated Arabic, like on their phones, they use digits that look like the Arabic letters, and that's a common thing. Or chui. For the letter ah, which is not on your keyboard, they use it backwards. So if you were to split these things apart, now all of a sudden this really common word that means them, or it's a pronoun, it's super common, would become 3 separate parts. So choosing what these units should be, this vocabulary of tokens. Should it be words, right? Okay, well, words, the space of words is truly infinite. You can't have all of them. What we want to do though is have a vocabulary where we can see connections between things. The model can't see inside of a token, so it can't see, for instance, that the elephant and elephants are the same. So we generally try to break pieces, break words apart into smaller pieces, and this also brings up problems. So some languages, this notion of a root and an affix doesn't really hold because the root changes, right? So it's not like the root stays constant, or a language like Arabic where the root is mixed in, and so breaking apart can also cause other sorts of things. The model is also not seeing commonalities that you or I might see. Like the fact that this word book is very similar across lots of languages, but it appears differently, and so the model needs to kind of learn all of this from context. Transliterated forms of language are similar, where often the orthography is not standardized. Hebrew and Arabic, right, don't write vowels, which introduces additional ambiguities. And so if the model is trying to implicitly learn the connections between these languages, it's got to infer these kinds of things. The languages in India, right, are all related to each other, but many of them use separate alphabets. So this is, going back to this idea of how speech might help us, right? You have languages that are, that sound very similar, or the Hindi Urdu example is actually a really good one, where, it's for historical and political reasons, you have this Arabic script versus, Devanagari script and all these things, kind of, and Japanese has sort of similar things. And so I just wanted to kind of give a sampling of this notion of, we'll just do all the languages, except you have all these interesting differences that the model has to figure out how to handle all on its own. Thank you.
Thank you very much to all 4 of you. As we've been doing at the conference, we'd like to give the panelists a chance to ask a question of each other. I know the three of you know each other quite well, but still you probably enjoy talking about and asking questions of each other.
So
And
I
then
should be the one to ask questions.
I think maybe.
Well, I have a question actually, or a short comment again, as a non-technical end user, but it seems to me that we are very far away from a universal translator, or just a model that can encompass, And I was very interested in the SIEM full, because I can see the applications in a lit lab, in which that, which is not utilitarian translation, but some sort of different level. And I was very interested in the idea that you're now looking at, humanists too, because of course that's can only be a collaboration. But my question, and this is a real question, is what do you think about what would be the goal, of the common goal of a collaboration? Because that's something that is not entirely clear to me. So for me, for instance, experimenting with translating the Cameron into English, or comparing different translation into English and other languages of an Italian text that I know well, and so I can I can see it. But for the making the models better, that's what I think is your perspective, and all of you, in fact. Is that a clear question, or
Yeah.
fairly?
Yeah, I'm happy to chime in, and then you guys want to chime in too. So I think one thing I've been very excited about right now, with like where I say there's this kind of like need for the collaboration, is like the surprising amount of application that is suddenly, like, sometimes you think of these as academic pursuit, and I mean, honestly, a lot of it's just interesting. Like, these are interesting questions, and we want to sit in our ivory towers and talk about them. But AI has suddenly become very interested because there's sometimes small, sometimes big practical applications. So some of the examples, like I talked about, that kind of synthetic analytic distinction in this gender bias, we kind of got into this because there's probably implications for the regulation aspect of it, right? Like, the model might be deemed biased if it's encoding gender on a non-gendered word at the level of the meaning of the word, but not if it's inferring it from context. For example, you could say there's nothing wrong with saying, well, statistically, most nurses are women, so I'm going to assume the nurse is woman. That there's not a bias in the model. That's just making a reasonable decision. But if you've encoded femininity as part of what it means to be a nurse, that could be a problem. So that actually could have implications for how we regulate our auto models. Something like, does the model understand something, or does it mean something, could have a lot of implications for like different types of rules around what level of AI you're allowed to use for certain types of applications. And you might say, like, for evaluating a model and saying, how is it, how intelligent is it? So something like a medical application, you say, like, you can't use a model that doesn't have this level of understanding. And so suddenly we want a formal notion of understanding to say it needs to have at least this amount of ability to make certain types of, like formalizing those notions actually, and when I talk to people in AI, there's kind of this assumption that, like, we can do it, we can evaluate stuff. Like, I've been in a lot of workshops of like human level understanding AI, and I'm just like, I don't think we know what human level understanding is. Like, we've been debating that, and suddenly it's like, okay, let's call in the philosophers. Like, philosophers, you guys have been working on this, so like, tell us what the answer is, kind of a thing. And so I think there's this healthy timeliness to it, where it's like, kind of like, okay, we have these big questions we've been debating, but now we actually kind of need something somewhat actionable about it, or at least be able to say, this is an unanswerable question, and so you can't write regulations that depend on a notion like understanding, and here's why. And I could come up with other examples too, but I think there's a lot of these like quite tangible things.
So I can also speak to like the complementarity I see. So in the case of translation, I think there's a lot we can learn from understanding, trying to support what people need. I think the task of machine translation has historically been framed as text in, text out. And that's just really limited, right? That's just trying to mimic like what human translators do on a very simplified level. But to support people to communicate across language barriers, maybe that's not all they need. Maybe just translating the text is not the right thing to do. Or maybe in some scenarios you want to use translation to support more creative endeavors, and so you want to help people explore different options and so on. So I feel like there's a lot that we can learn from collaborations in terms of complicating the task a little bit, and hopefully in ways that make them more useful. I think also kind of related to the question of meaning and formalizing things, I've mentioned many times in passing, like translation quality. Is a translation good or not good? And that's a hard question. Like, what is a translation good enough? We have very simplified ways of thinking about that and of operationalizing that. But especially now that the tools are used in many, many different settings, thinking about what that means, how to measure translation quality in many different ways, is a place where we definitely need input from others. So I think these are two directions where I see a lot of potential.
Well, there is no perhaps a precise way of evaluating how good a literary translation, certainly even in the same language. Anyway, sorry,
Right.
yeah. So the thing where I have in my academic work, especially seen this come up a lot is people that are just used to thinking about problems and the world and data in specific ways where so I give that chart with Wikipedia, right? Wikipedia is a great source of information and knowledge, and it's very factual and all these things. And I've had people with humanities backgrounds and say like, yeah, but also like we know that Wikipedia is mostly written by English-speaking young white men, right? So it's coming with this specific context. And yeah, we need people who are thinking about the world in those kinds of ways to bring all of that in. None of us come with all of the knowledge, and a lot of the things that I was talking about here are things where it's not a coincidence that the examples of the way these current systems work happen to work well for English and not so well for other things, right? Because they are actually built by people who speak English, not necessarily as a first language, but almost certainly as a second language. And they're thinking about English while they're doing it. And so, there's often this attitude of, okay, well, we'll get it working for English because that's the priority, and then we'll just flip it and make it work on other stuff. But doing so, I mean, I think there are a lot of ways in which people don't realize that when you make choices about English, you're steering the direction of research in a way that is less compatible with the way that other languages function, and being able to bring in that context initially and say like, ooh, that's actually not going to work out in the long run, and this kind of thing, I think is very important.
Yeah, I think this is an interesting, with just the crossover between disciplines, because sometimes people sort into disciplines because they have preferences for how to approach problems, and then you get stuck. And so exactly this, a lot of people who are building AI technology, people going to computer science, like to think in this rigorous, rigid way, and so it's exactly this problem, like what Marine's saying with how do you evaluate translation? And I've had a lot of conversations with people where it's like, okay, well, we don't have to use this metric. Just give us a different metric. As long as it can be a number. And it's right. And it's just it's so built in, oh yeah, we can tune to maximize ethicalness. Just tell us how to measure ethical. And it's just a fundamentally different way of thinking. And so you can imagine if you have people who are just coming in from the beginning, not thinking about it like that, and forcing that conversation really early on, then it's a full redesign of,
Yeah, and the other thing I like to think a lot about with measurement is this notion of how good is should AI be, these kind of things. Well, it should be like a human, but for a lot of things it should be better than it. If you judged your calculator by whether it could do math like a human, that would be a bad calculator. There are lots of things that should be better than a person can do them. And so thinking about what these kinds of problems are, and what should be the goal of these types of systems, I think depends a lot on the context.
Great. And now we have questions from the audience.
Hi. Sorry. My question is for Dan, I think. I've been thinking a lot about representation and how the systems we're building for modern times kind of leaves behind many communities and languages. And I speak, of course, as an African who speaks Yoruba as a first language, where speech tools exist in smaller languages like Norwegian, Danish, etc., but doesn't exist in many big, large African languages that have speakers and users. How do you think about this when you're building systems like this that take a big leap of technology forward in terms of the data that's available in many of these languages? And how does a company like Google think about bringing and carrying those small language communities along? Thank you.
It's interesting. So, as a field, as a field, I mean, the field has changed dramatically in the last couple of years, as everyone is aware. But it used to be that if you wanted to, the stuff that I did like for my dissertation was okay. So if you don't have a lot of data for a language, well, what do you need? We need really high quality, data, very specific, lots of information. And we've shifted to this model where, as I was showing, like now the models that we're building are just, they're doing this incredibly simple thing, and the only way they can learn is just by feeding in tons of data. And so now, like, the importance of having that very rich data is kind of less important, and we just need volumes of it. And that's a harder thing to just manifest. I think in particular that for a lot of languages, and not just a lot of languages, but a lot of variations of languages, or different levels of formality, or different cultural speaker groups, switching to bringing things in from speech is actually another place where we can get a lot of value. So the example I would give is stuff that's written on the web tends to be somewhat formal and of the kind of standardized versions of things, but like people on TikTok, they just talk how they talk. And I think you can get, I think you could gather more data in a way like that. And so, like expecting that Yoruba Wikipedia is going to suddenly become as big as, English is, or worse, predicating your work on just like, oh, well, as soon as its Wikipedia gets to be the size of English, then it'll be fine, is certainly not a way to do it.
Hi, thanks so much for that fascinating panel. I just wanted to ask a little bit more, try to understand a bit more about how AI translation can kind of negotiate between different kinds of language difference. So this is just kind of picking up on what you were just saying about. So, I mean, what I loved about Marine, your presentation was the sense of translation not happening between one language and another language, but negotiating between smaller communities. And my understanding of how things have shifted over the last year is that, a year ago, Google Translate was translating between standardized versions of languages, and now you can ask an AI to do a much more particularized kind of translation. You can ask it to translate into 18th century English, or into the style of Henry James, et cetera, or into multicultural London English, for instance. And it produces results. But there's a whole lot of, so one of the things, so to an extent, I love that, because that's moving away. So my broad brush sense of sort of the kind of domain of translation is that there's the version of translation which is created by print culture and colonial nationalist kind of ideologies, which says translation has to operate between standard languages. And then there have been all kinds of critiques of that, saying, no, we need a more fluid sense of what I call translationality, which is kind of negotiating that translation is a means of moving across language difference rather than between several languages. So it seems to me now we have the opportunity to sort of do that kind of translationality, and which is fantastic. There's a kind of utopian possibility there. But then there are that creates lots of problems as well, because how do you define? So with the old idea of translation, it was clear actually there's the switch around that says, well, it's translation that creates languages. Why do you have a standard language? You have an idea of a standard language because when you're in print culture, you need something that a translation can happen into. But now with the world that you're all working in, and in fact, which is much closer to the just world of everyday language use, you say, well, okay, I can I can translate it into anything. I can translate it, but I wouldn't want So partly, so my first question is, how does I don't know how do these systems come up with what they think of as kinds of language? So I can understand how it can come up with the style of Henry James, but if and it connects to Kolo's question, if you've got a speech community, say Oxfordshire dialect, I mean, it probably couldn't do Oxfordshire dialect because it doesn't have anything to build on. But I think there's a whole set of ethical and political issues there around what gets registered as an identity that translation can happen into. And then I think there's a whole set of other questions around what I would want, because would I want Tolstoy? So presumably, I could give it a whole load of my language and I could ask it to translate Tolstoy into my English. But I wouldn't want that. That would be a horrible reading experience, because part of what one wants when you're reading, so that makes visible the fact that when I want something to be translated into, in what has hitherto just been English in inverted commas, I don't really want it to be translated into my language. I want it to be translated into language that is different in a particular way. Anyway, so those are the considerations that I have. But I just wanted to ask you, for this sort of idea of translation mediating through a continuum of language difference, and how you, whether that kind of speaks to your work, or how, I don't know, that was the perplexity I wanted to share.
I'm happy to kick off, and then so I think it's a really interesting point about where do you draw these boundaries, right? Like what are these named languages that you could ask it to translate into? And as we've been moving more and more to these, the current method of things, like really what's at the core of these models, whether they're doing translation or anything else, is this pattern matching ability, right? And so actually outside of translation, a lot of what people do is you're asking the model to perform a particular task by showing it a few examples and hoping it continues the pattern. And so like you can imagine translation kind of falling on this continuum, like how if you wanted to do something like French, going from English to French, something that there's a ton of examples on the internet and it's heard these named as English and French, it already has like a really good sense of the kind of next token prediction sequence around words like English and French, and it can do what kind of following what Dan was doing. But these, like, as you get these like more finer grained nuances getting down to like, and you could go arbitrarily far, like you said, your particular idiosyncratic language, it might need more examples of that. The models aren't perfect, but the kind of hope for this is you would basically, the number of examples you'd have to give a human, because you couldn't just say like, oh, speak as this person does if they don't know you super well, right? So you take a couple examples and then they can infer from that kind of your style or idiosyncrasy and continue in like way, right? And so I think that's what the models are getting increasingly good at doing, is not just learning the patterns they see in their training data, but given these in-context examples, what it's called inferring the kind of little micro pattern and then running with it, right? And so I think you can imagine that's, then you don't actually need named languages, or you don't have to define these, because you're just basically going by example. And that's where a lot of the excitement in AI right now has been, is this ability to give these in-context examples, because it breaks you out of having to predefine and create data sets for a given task. And the same could go for language, right? Like you could just say, as long as you can show some examples, and if the pattern is kind of inferable from those examples, the model hopefully can extrapolate. Again, it's kind of an idyllic view, right? But I think that's where.
So we're short on time, so I think we're gonna leave the responses there. But if you could, we have 10 minutes where Matthew could go and get Dan's answer directly. I know Massimo has to head off to his next commitment. So thank you very much, and we appreciate all your input. Thank you very much.